Hey, Algebra 1, y'all. It is lovely to see you. Wonderful to have you here, quote unquote, here. It is time for another review video, getting you ready for that final quiz. Why don't you pause this and do the warm-up? All right. I hope you did the warm-up. It helps you get into that math brain. And the question is, does this graph show a picture of a function? And what we talked about earlier this year about functions is that all lines are functions. And so, yep, definitely. There's also a test that you can run when you have the graph of a, any kind of graph. You can draw vertical lines through that graph. And if your vertical lines, no matter how many you might put in, a whole infinity of them, if they only cross that graph in one place, then you know that it is what's called a function. The vertical line test is what it's called, and that shows that that graph is definitely a function. So we're going to be talking about functions and forms today. This week is all about review. Today, functions and forms of equations. So if you're ready to update that notebook, it's time to do this. Excuse me. On Friday, you're going to be getting your final quiz, and then that's it from Miss Wade for the rest of the school year. Oh my goodness. So we are going to be touching on a few things. First of all, how to tell if a relation is a function, and then how to tell and identify linear functions, and then some forms of equations. So here we go. So functions can be described in many ways. You can have an equation that describes a function. There you could have a table. You could have words, a graph, a set of ordered pairs. What we're going to talk about is how you can tell if a relation is a function. Now, relation and function mean a couple of different things. Relation means a set of pairs, like the dots you see on this graph. That's a set of pairs. A function is a set of pairs where each input or x value has exactly one output or y value. So when we're looking at this graph right here, this series of dots, we can take a look at the input of 0. And when we take a look at 0 and we go up to the output, which is 8, we see that there is only one dot there, and so far this is good. When we go to the output of 1, which is right here, we can look up to the input of 1, we can go to its output of 6 and see that there's only one dot. When we go to the input of 2, we have an output of 4, input 3, output 2, input 4, output 0. And so yes, this is a function because every input has exactly one output. So when we're looking to see if these relations represent a function, we're really just looking to see if every input has exactly one output. So for example, in part A, this is a relation because it's a series of pairs. Notice that -2 only shows up once in this, so -2 is an input. And -2 doesn't have the output of 2. -2 does not have any other output. It doesn't show up anywhere else in this list. It's not here, it's not there, it's not there, and it's not there. So we checked out -2, it seems to work. When we look at -1, we can see that it has an output of 2. That's okay. Is there another -1 in this list? Well, that's not -1. That isn't, that isn't, that isn't. And so far we're good. Now we look for the zeros. Here's an input of 0 and an output of 2. So, is there another input of 0 on this list? There sure isn't. What about 1? Is there another 1 in this list? Nope. What about 2? No other 2. So every input has exactly one output. And so this is a function. Now that's different from this list. Because notice you have an input of 4 here and an output of 0. But you also have an input of 4 here and an output of 3. And so 4 goes to 2 different places. You could put a 4 into this machine and it might spit out a 0. Or you could put a 4 into this machine and it might spit out a 3. You don't know. And so this is not a function. Every output for every input. We can do this on a table as well. As we look through these inputs in the top row, we have -2, -1, 0, and 0, 1, and 2. Notice that 0 goes to 5, but 0 also goes to 6. And so if we can think of a function as a machine, if I'm putting 0 in, I might get a 5 out, and I might get a 6 out. And so this ends up not being a function because you can't have 2 outputs for a single input. Another way of looking at this is through this kind of table here. Notice that for every input x, there is only one output y. -1 goes to 4, 3 goes to 15, and 11 goes to 15. Now it's okay if these two go to the same one. They just don't have 2. In other words, we don't have something like this. So yes, this is a function. Being able to tell functions is kind of confusing. It's even confusing for me sometimes. It's okay. There won't be a lot of questions about that. This is where being able to tell a function actually gets pretty easy. Because like in the warm-up, we talked about the vertical line test. And if we draw vertical lines through these graphs and we find that they only hit the graph in one place, then we know it's a function. This one, if you draw vertical lines through, you'll see that it only touches that graph at one point. So yep, that's a function. Now look at this one. I can draw this vertical line right here, and it hits this graph at 1, 2 different places. So this is not a function. And then this one, I can draw vertical lines all day. I'm still only going to hit that graph at one place. So that's a yes. That is a function. So, functions, they're fun. So then we started talking about linear functions, and linear functions are lines. And really, the easiest part of identifying linear function is this a line or is this not a line? It's that simple. So part A is a no, because that is a curve, not a line. B is a line, so yes. Linear, nonlinear. I guess it asks for linear, nonlinear. So this is nonlinear, and this is linear. You can tell the difference because a linear function is a line. All right, so then we started talking about forms of equations because equations describe functions too. And we are trying to figure out all the different ways that we can express a line. And it's all in this chart right here. Linear equations come in many forms. All of these make a line when you graph them, and each one is useful in its own way. And so if you want, we have been through this a few times. We have the slope-intercept form, the point slope, the standard form. We didn't really use the intercept form, so that one isn't very useful. We saw vertical lines, we saw horizontal lines, and these equations are their form. This is what their equations will look like, basically. And the idea is that you want to take an equation and match it up to its form. So for example, if I have an equation that says y equals 2x plus 4, I'm going to look through this chart and look for a form that looks like that. And it's really the top one. See how this has y equals mx plus b, where m and b are numbers, a slope and a y-intercept. That means this equation is a slope-intercept form. To just being a matter of recognizing what that looks like the most. What about this one? Well, let's see, it's not slope-intercept because in slope-intercept, the y is all by itself on the left, so it's not that. Point-slope form, well, this equation doesn't have any parentheses in it, so it's not that. What about standard form? It looks like we have a positive number, we have a number x, and then a number y, and then a number. Oh yeah, that's what we have, 2x plus 6y equals 12. So this is what standard form looks like. It's just the general name for that type of equation. All right, well, looking at this one, we can match it up. Let's see, this one doesn't have the y all by itself, so slope-intercept doesn't work. Oh, but point-slope looks like it might work because we have a y minus a value equals a number and some parentheses. Yep, this is definitely point-slope form, definitely. All right, that's it. Not much to talk about. You've got a little bit of a review, quizzes hanging out, waiting for you. Go enjoy. Let me know if you need help. Bye-bye.